So again, whatever we don't go over today, we'll go over tomorrow, and I'll post the answers tomorrow also in a PDF. So looking at number 1, how many different batting orders can a baseball coach create from a team of 14 players when there are 9 positions to fill? So what should we do here? So we have 9 different positions, so we can draw 9 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we would start with 14. But if I have somebody in the first spot, they can't also be in the second spot. So 13, 12, 11, 10, 9, 8, 7, 6. So we could do it this way and then just multiply all of these numbers together. A different way we could think about it is that if I had 9 positions to fill, if I put players 1 through 9, just like that, that's one position, that's one batting order. But I could also do it backwards and do like players 9 through 1. That would be a different batting order, even though it's the same 9 people. So does the order matter here? Yes, the order matters. So would it be a permutation or a combination? Permutation. So we could do 14 is the total number, and we're picking 9. So this would be 14 factorial over 14 minus 9 factorial, which is 5. So if you notice, the math will be the same. It's technically the same thing. So if it's a combination, our formula would be n factorial over n minus r factorial times r factorial. So it's a little bit different.
And this one's just n over r?
It would be, this one's n. Oops, oh no. Would be n factorial over n minus r factorial. So it doesn't have that extra r factorial on the bottom. What did you guys get when you multiplied all these together? Anybody? 7, 2, 6, 4, 8, 5, 7, 6, 0. So no matter which way you do it, in the red or in the blue, it'll give you the same answer.
And why does order matter here?
Because if I had players on my team, so let's say I had players 1 through 9 in my batting order. I could also have players 9 through 1, which this would be a different batting order. Even though it's the same 9 people, the order matters because you could have players 1 through 9 or 9 through 1, and it's 2 different orders. So the order matters, that's why it's a permutation. For number, yes. If order didn't matter, then it would be a combination. So for number 2, so consider that 8 sprinters have qualified for the finals in the 100-meter dash at the NCAA National Track Meet. In how many ways can the sprinters come in first, second, and third? Assume that there are no ties. So I only care about first, second, and third place. And I have 8 sprinters. So it would be 8 times 7 times 6. So again, you could do it this way. Or it's also a permutation, so you could do 8, pick 3. And you'll get the same answer. So 8 times 7 times 6, 336. All right, number 3. Here it says distinguishable permutations. So we take the total over the repeated. So total factorial over repeated factorial. So the total amount of letters I have is 1, 2, 3, 4, 5, 6, 7. 7 letters total. L repeats how many times? Twice. Does G repeat? A repeats how many times? 3. So that goes on the bottom. Does R repeat? Nope. So it would be 7 factorial over 2 factorial times 3 factorial. So we could write this out. 7 times 6 times 5 times 4 times 3 factorial, and I know that'll cancel out with the 3 factorial on the bottom, so it'll be 2 times 3 factorial. So these cancel. And then 2 goes into 4 twice, so it's 7 times 6 times 5 times 2. Yep. Number 4 is the same thing, distinguishable permutations. So how many letters total do I have? 10. So 10 factorial. Q doesn't repeat. P repeats twice. D repeats how many times? 3. And E repeats 4 times. So this would be 10 times 9 times 8 times 7 times 6 times 5 times 4. I can stop there because I have a 4 factorial on the bottom. So it'd be 2 times 3 times 2 times 4 factorial. These cancel. 3 and 2 cancel out with the 6. 2 can cancel out with the 8, and it goes in 4 times. So 10 times 9 times 4 times 7 times 5. This is 12,600. In a certain state, each standard automobile license plate number consists of 3 letters followed by a 5-digit number. How many distinct license plate numbers can be formed in this state? So we start with 3 letters followed by a 5-digit number. So how many letters do I have totaled? How many options do I have for this first spot? 26. There's 26 letters. What about the second spot? 26 again, because it doesn't say that I can't have a letter that repeats or anything like that. It doesn't give us any restrictions. So I could have 26, 26, and the third one could also be 26. What about for our 5-digit number? How many possibilities do I have for this first spot? 10. And what about the second spot? 10, 10, 10, 10. Because again, I don't have any restrictions there. So because I have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 different numbers that could be there. Yes.
So this is a specific order. This is considered a combination.
So this would be, and then 5 zeros. A big number. 1,757,600,000. Okay, number 6. In 1963, the United States Postal Service launched the Zoning Improvement Plan, zip code, to streamline the mail delivery system. A zip code consists of a 5-digit sequence of numbers. Find the number of zip codes consisting of 5 digits. So 1, 2, 3, 4, 5. How many different possible numbers do I have for this first spot? 10. What about the second spot? 10. It doesn't give me any restrictions, so in all 5 spots, I have 10 possible options. So this is, yes, 100,000. Okay. B. Find the number of zip codes consisting of 5 digits when the second digit is 1 or 9. So again, we have 5 digits, 1, 2, 3, 4, 5. Our second digit has to be the number 1 or number 9. So how many possible options do I have for the second spot? 2. What about for the first spot? 10. It doesn't give me any restrictions for the first. What about the third? 10. Fourth? Yep. The only restriction is on that second digit. It could only be a 1 or 9, so it only has 2 options there. So this would be 20,000. All right, number 7, super similar. ATM personal identification number, the PIN codes, typically consist of 4-digit sequence of numbers. So find the total number of ATM codes possible. So 4-digit sequence. How many different numbers could I put in my first spot? 10. What about the second spot? 10, 10, 10. Doesn't give any restrictions. So this would be 10,000. For B, find the total number of ATM codes possible when the fourth digit is not 0. So how many different possible options do I have for the first digit? 10. Second? Third? What about the fourth? How many different options do we have for the fourth spot? 9. Because the fourth digit is just not 0. It could be anything except 0. So this would be 9,000. So starting with number 8. A college student is preparing a course schedule for next semester. The student must select one of 4 mathematics courses, one of 4 science courses, and one of 2 courses from the social sciences and humanities. How many schedules are possible? What should we do here? Yep. We're picking one of 4 math, so there's 4 options for that course. One of 4 science, so there's 4 options for that one, and one of 2 of the social sciences, so there's 2 for that. So 4 times 4 times 2 would be 32. Number 9, a customer can choose one of 4 amplifiers, one of 9 stereo receivers, one of 10 speaker models for the entertainment system. Determine the number of possible system configurations. What should we do here? Same thing. So we have 4 options for the amplifier, 9 options for stereo, and 10 for the speaker. So multiply these together, it would be 360. Good with that one? In how many ways can a 14-question true-false exam be answered? So there's 14 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many different answer choices do I have for the first spot here, for that first question? 2. It's true or false. So there's 2 different answer choices there. And there's 2 for every single one. So this would actually be 2 times 2 times 2, 14 times. So 2 to the 14th power. Instead of sitting there and putting 2 in the calculator 14 times, you could just do 2 to the 14th power. So when we put this in the calculator, we get 16,384. Number 11, in a psychology class, a student must dissect 3 different specimens. A student can select one of 6 earthworms, one of 7 frogs, and one of 3 fetal pigs. In how many ways can the student select the specimens? What should we do here? Awesome. Same thing we did for 9 and 8. We just multiply 6 times 7 times 3. So 126. All right, number 12. Find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 1 green, 2 yellow, and 3 red marbles. So the probability that both the marbles are red. So I have 6 marbles total. How many red ones do I have? 3. So there's 3 out of 6 red for the first time I pick a marble. But it says without replacement. So I take that red marble out and put it on the table. So what should I do next? Multiply 2 over 5. Because now we only have 2 red marbles in the bag. And 5 marbles total. Because I took that marble out and put it on the table. So there's 1 less. Then when we multiply fractions, multiply straight across. So this would be 6 over 30. Make sure you simplify your fractions, so that would be 1 over 5. So 13 is one of those neither ones. So again, when it says both or neither, these mean and. So we would want to multiply. So find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 3 green, 3 yellow, and 4 red marbles. So here I have 10 marbles total. I'm trying to pick a marble that is not yellow. So how many not yellow marbles do I have? 7, because there's 3 yellow ones. So the ones that are not yellow, there's 7. So I take a non-yellow marble out of the bag. Now how many marbles total do I have? 9. And how many non-yellow marbles do I have? 6. So we multiply straight across. 6 times 7, 42 over 90, and we can simplify this. They're both even numbers, but I think 3 goes into both of them. 6 goes into both of them. Yep. So 7 over 15. Right, 14. Find the probability for the experiment of selecting one card from a standard deck of 52 playing cards. The card is a face card. So you guys have to know the characteristics about the cards in a deck of cards. You won't get the deck of cards. How many face cards do I have in a deck of cards? Face cards. 12. Because face cards are Jack, Queen, and King, and there's Jack, Queen, and King in all 4 suits, so it would be 3 times 4, which would be 12. And then how many cards total? 52. And then I can simplify this, divide them by 4. So 3 over 13. All right, 15. Find the probability for the experiment of selecting one card from a standard deck of 52 playing cards that the card is a black card. So how many black cards total do I have? 26. And how many cards total? 52. And then I can simplify this, so it'd be 1/2. Or you could also just know that half the cards in the deck are black cards, so 1/2. So 16 says that I'm picking one playing card, and it is a card numbered 2 through 10. So 2 through 10, I have 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 9 cards there. So 9 cards that are 2 through 10, but how many total do I have that are numbered 2 through 10? 36, because I would have to multiply this times 4, because there's 2 through 10 in all 4 suits. So 36 over 52, which simplifies to 9 over 13. 17. So use the table which shows the age groups of the students in a college sociology class. A student from the class is randomly chosen for a project. Find the probability that the student is the given age. So younger than 22 years old. So younger than 22 would be the 19 and 17 added together. So it'd be 19 plus 17. And then how many total do I have? How many students total? 39. So this would be 36 over 39. And then we can simplify this. So 3 goes into both numbers, so 12 over 13. One card is selected at random from a standard deck of 52 playing cards. Use a formula to find the probability of the union of the 2 events. So the card is a face card or a black card. So how many face cards do I have? 12. That's a Jack, King, and Queen in all 4 suits. So 12 out of 52. It says or, so that means what? Add. And then how many black cards do I have? 26 out of 52. Are there any face cards that are black cards? How many? So I have to subtract those 6 overlapping ones, because there's 6 cards that get counted twice here because they're face cards and black cards. So anything that overlaps, you have to subtract that. So then we add all these together. So it would be 32 over 52, which simplifies to 13. 8 over 13. Right, one card is selected at random from a standard deck of 52 playing cards. Use a formula to find the probability of the union of the 2 events. The card is a heart or a diamond. So how many heart cards do I have in a deck? 13 out of the 52. How many diamond cards do I have in a deck? 13. It says or, so I add it together. Are there any heart cards that are diamond cards?
No.
Nope. So I would just add these two. So it'd be 26 over 52, which is 1/2. So use the table which shows the age groups of the students. Same question from before, but now we have students 18 to 21. So 18 to 21 would be from here. So I have 14 plus 12 students that are 18 to 21, so that would be 26. And there are 30 total. And then we can simplify this, so 13 over 15. All right, it's 21. You can answer any 16 questions from a total of 20 questions on an exam. And how many different ways can you select the questions? Would this be a permutation or a combination? Combination, because the order doesn't matter. We could have questions 1 through 16 that we answer. We could also answer questions 16 through 1, but those are the same 16 questions. So the order doesn't matter here, so it's a combination. So this would be 20 total, and we're picking 16. So 20 factorial over 20 minus 16 factorial times 16 factorial. So 20 times 19 times 18 times 17 times 16 factorial, but I have a 16 factorial on the bottom, so I know that'll cancel. And then I have 4 factorial, which would be 4 times 3 times 2 times 1. So the 16 factorials cancel. I can simplify a little bit here. 4 goes into 20 5 times. 3 goes into 18 6 times. And 2 goes into 6 3 times. So 5 times 19 times 3 times 17. So 4,845. So for this one, you guys can put this in your calculator, the factorials, but just make sure you show your work. So for questions like 21, make sure you show your work. So if I have a group of 30 people and I'm picking 12 for jury duty, doesn't matter if I pick like me, Ryan, Jackson, or Jackson, Ryan, me. Are those two different groups of people?
No, but I just thought once you select one, you can't select another. You know what I mean? Like.
So this one again, it would be a combination. So it'd be 30, choose 12. So 30 factorial over 30 minus 12, so that would be 18 factorial times 12 factorial. And we can put this in our calculator. So I got 86,493,225. Also, if you're going to put this straight into your calculator, make sure you put the denominator in parentheses. I mean, there's different ways that you can put this, but if you do it all at once, put the denominator in the parentheses, because sometimes it might take 30 factorial, divide it by 18 factorial, and then multiply it by 12 factorial. So just make sure you put the bottom in parentheses if you do it all together. Okay, 23 we talked about yesterday a little bit. So law office interviews paralegals for 10 openings. There are 15 paralegals with 2 years of experience, 22 paralegals with 1 year of experience. How many combinations of 6 paralegals with 2 years experience and 4 paralegals with 1 year experience are possible? So we're kind of choosing from like 2 different pools here. And then since the numbers go together, it's this many with 2 years experience and this many with 1 year experience. So since it's and, we multiply them together. So it's combinations for both of those. So I find the combination of 15 and 6. So that would be 15 factorial over 15 minus 6 factorial, so 9 factorial times 6 factorial. So 15 times 14 times 13 times 12 times 11 times 10 times 9 factorial. That'll cancel out with the 9 factorial on the bottom. And then I have 6 times 5 times 4 times 3 times 2 times 1. So I can cancel out the 5 and the 3 with the 15, the 6 and the 2 with the 12, and let's see, 4, I could take out a 2 from 14, be left with 7. So I have 7 times 13 times 11 times 10 on top divided by 2. So I get 5,005 here for the first one. Then I'm going to have to multiply that by 22, choose 4. So here this would be 22 factorial over 22 minus 4 factorial would be 18 factorial, 4 factorial. So 22 times 21 times 20 times 19 times 18. I can stop there. 18 factorial, 4, 3, 2, 1. So 4 goes into 20 5 times. 3 goes into 21 7 times. And 2 goes into 22 11 times. So this would be 11 times 7 times 5 times 19. So this is 7,315 times 5,005. So 36,611,575. All right. And then 24. In 2013, there were approximately 11.46 million unemployed workers in the United States. The circle graph shows the age profile of these unemployed workers. Estimate the number of unemployed workers in the 25 to 44 age group. So that would be this age group. So it's 39% of the total amount of people, which is 11.46. So it would be 11.46 times 0.39. So that would be it says 2 decimal places, so 47 million people. For B, it says estimate the number of unemployed workers who are 25 years or older. So 25 or older would be 39%, 29%, and 3%. So I'll add all those together, 39 plus 29 plus 3. So that would be 71% of the people are 25 or older. So I have to multiply that times the 11.46, the total amount of people. 71. So multiply it by 0.71. So 11.46 times 0.71. So that would be 8.14 million. All right, C is a little bit different. This one asks for the probability that a person selected at random from the population of unemployed workers is in the 16 to 19 age group. So 16 to 19 would be this one here. So that's 12%. So the probability would be 12%. For D, it also asks for the probability, so that'll be a percentage too. What is the probability that a person selected at random from the population of unemployed workers is 20 to 64? So this one's 20 to 64, this one, oh, just those three. So it'll be 17 plus 39 plus 29. So it'll be 85%. And then E says, what is the probability that a person selected at random from the population of unemployed workers is 45 or older? So you have 45 or older here and here. So that'll just be 29 plus 3, so 32%. So remember, if you don't know Pascal's triangle, you can start it by making a little triangle of ones. Always start with a 1 and then add the 2 numbers above. So the second row would be 1, 2, end with a 1. Start with the 1, add the 2 numbers above, 3, add the 2 numbers above, 1.
I was watching Meadows' video and she said that we're doing like triangle.
And then also, this question came up before, the row number. So the number that you're looking at, if I had, let's say, x squared plus y to the 4th power, I'm looking at the 4th row, so the second number tells you what row that is. So the 4th row would be the one that has the 4 in it. So I would use 1, 4, 6, 4, 1 as my coefficients. Remember, we start with the first term, so x squared, and then it'll be to the 4th power, x squared to the 3rd power, x squared to the 2nd power, x squared to the 1st power, and then x squared to the power of 0.
So what one would be like?
I'm going to change this. Let's say it's 2y, so it'd be 2y to the power of 0, 2y to the power of 1, 2y to the power of 2, 2y to the power of 3, and 2y to the power of 4. Don't forget, when you have a coefficient in front of your variable, you have to distribute. So it'll be 2 to the 4th power and y to the 4th power. So that was a common mistake on the quiz that you guys took last week. So people forgot to distribute. That was probably like the only mistake that people made, is that they forgot to distribute. And then when you have an exponent raised to an exponent, you have to multiply those 2 numbers. So your first term here would be x to the 8th power.